Welcome to the lecture portion of the Ultraviolet Visible Spectrometer, or UV Vis spectrometer. My name is Tracy Holbrook, and I'm the lead instructor for the Chemical Technology program. And you are watching the series of videos because you are one of two groups of people. First, you could be one of our own ChemTech students that are utilizing these videos to supplement the lecture material that they are receiving in the classroom. So if you're one of these, welcome. Hopefully you'll learn something new in these videos, maybe that you didn't quite get in our lecture portion of the class. Or you could be a ChemTechathon student. So you are a member of a team from a local high school, and you are watching these videos because you want to know what UV Vis spectroscopy is all about, and what is the purpose of the machine and the instrument, and how to do the data analysis. So whatever your background is, welcome to the lecture videos. The videos will be broken down into three portions. The first portion will be focused on the theory and the background and the math that's associated with UV Vis. The second portion will focus on the instrument pieces and parts. What makes this machine work? What pieces and parts are required in order for me to do analysis with it in a laboratory? And the third portion will finally be the data analysis portion. So what can we do with the numbers that we get from the machine? And then how do we utilize the software that you will be using to run our instrument? So without further ado, let's take a look at the instrument that you will probably be using mostly in our laboratory, whichever, again, group of students that you might be. And that's this instrument down here at the very bottom right-hand corner. This is our Thermogenesis 10S unit. And this is the instrument that all of the ChemTechathon participants will be trained on. And this is also what we would call the newest or latest and greatest UV Vis instrument that we have in our laboratory for our ChemTech students. So if you're a ChemTech student, you have used an older version of this machine called the Cecil, and this is the newer, more industry-grade machine that you might see when you get a job in a laboratory. So before we go any further, we want to make sure that we have a couple of things clear. And one of these is, what is the definition for UV Vis? So let's pause for a moment and take a look at some of these definitions or some of the terminology that might creep up throughout this first portion of the lecture videos. So let's talk about this definition of UV Vis. Right off the bat, we're talking about this instrument. We're calling it a UV Vis. What does the UV and what does the Vis represent? Okay, so first off, this UV portion is standing for ultraviolet. And the visible, or Vis, stands for visible light. Okay, so we have a machine here that is using ultraviolet light and visible light in order to do its job. Okay, so that's the very first thing that you have to realize. Okay, so what about this light material, right? Okay, well, you've often heard of this thing, and maybe in a science course that you've taken up to this point, something called the electromagnetic spectrum. And this is where really all radiation and energy come from. So the electromagnetic spectrum includes things like the Vis portion, which are visible colors. These are colors that you see with your eye, and we often call these Roy G. Biv for red, orange, yellow, green, blue, indigo, and violet. Any color that you're seeing with your eyeballs, we call that the visible region because we can see it, and that is part of what we would call a larger band of light called the electromagnetic spectrum. So visible is just a small portion of the entire region that's out there. We can't see everything that's going on around us. We can only see this really small portion called visible light, and it's a very tiny sliver of what we can see. And there's so many other things out there that we want to talk about. Well, one of those is the UV portion. So this ultraviolet is part of the electromagnetic spectrum. So that means that's another piece on the spectrum. I can't see ultraviolet light with my eyeballs, but it's there, right? We know that it's there. If you go to a tanning bed, your skin will know that it's there if you lay in it too long, because those operate with a UV light bulb, very similar to what we're using here in this instrument. But these aren't the only two things that are there. Ultraviolet means, kind of superviolet, right? So on this Roy G. Biv scale, here is violet. So that means my UV will probably be on this side, superviolet. So if that's violet, this is superviolet. It's on that side of the visible spectrum. Some of the other things that are out there that we won't talk about, but we do have equipment that measures it, are things like infrared. Infrared is a very low energy light beam, and we abbreviate that as IR. You often see these infrared beds now, just like you see ultraviolet beds or tanning beds. The infrared beds are supposed to be good for your skin. It's supposed to help cover wrinkles up. It's supposed to help collagen production, make the cellulite go away, stimulate a little bit of antibody growth in your immune system, believe it or not. There's so many good things that we are learning about infrared light that it's becoming a staple in health spas and gyms. So infrared, infra means below. So here is the red portion, and that means that R, or infrared energy, would be on this side of the visible spectrum. But there's other things out there too. We've got gamma rays, and we've got X-rays, and we've got radio waves, and we've got microwaves. The list just goes on really. And this is making up the entire electromagnetic spectrum. Well, this machine that you will be using, the UV Vis instrument, only looks at UV and Vis. That is it. And that's why we're only going to be focused on these two portions of the electromagnetic spectrum. Okay, so let me just take a little bit of step back and talk about UV and talk about visible. Visible light can be good for you, right? There's no really concerns with visible light. Blue light, red light, green light, yellow light, whatever. It's not going to harm me. UV, though, can be very bad. And they tell you to stay away from UV light. And the reason is because it can burn your skin. It can cause cancer. There's so many health-related concerns with UV that we just want to limit our exposure to it when we can. So the reason is that UV is a high energy, or at least higher energy than visible. So higher energy. Higher energy means it packs more of a wallop when it hits you. So because of that, we burn from it. We go out into the sun, we get a sunburn. It's typically due to UV light. And if I can block that UV light, then I can block my sunburn. That's because the UV light that's coming from the sun is hitting my skin, and it's burning me, and it's hurting me. And that's because it's a higher energy wave. Visible, though, visible's okay. Right? I can go in and I can take a red light and put it onto my skin and not really have to worry about it. Or I can take a blue light bulb or a blue light and shine it on my skin and not really worry about it. These are lower energy waves than ultraviolet is. So this is the introduction to UV Vis spectroscopy. All right, now before we go, I just want to bring up a word called a spectrometer. A meter is anything, of course, that measures, right? So we have a lot of meters in the laboratory. This is one of those meters. It measures something. Well, if something is labeled as a spectrometer with the spectra or spectro out in front, then this represents light. So what a UV Vis spectrometer is, it's a meter that measures light. What light does it measure? It measures the UV and it measures the visible region of the electromagnetic spectrum. In the laboratory, we do have infrared spectrometers. It is a meter that measures the infrared portion of the electromagnetic spectrum. We have nuclear magnetic resonance spectrometers. Well, this is a meter that measures nuclear magnetic resonance, which really happens in the X-ray portion, it happens in the radio wave portion of the electromagnetic spectrum. We've got spectrometers that are specifically designed to measure each and every piece of this electromagnetic spectrum that we're talking about. But for us, we're only going to focus on the UV, ultraviolet, and visible portion of the electromagnetic spectrum. If you want to take a look at an electromagnetic spectrum, you can do that. Here's a representative of that spectrum. So again, we get this Roy G. Biv that happens here. Violet, of course, is higher energy than the red. And ultraviolet is even worse. I want to stay away from those beams. And then X-rays happen above that, so I want to stay away from X-rays and minimize my exposure from it. And then above that is, of course, gamma rays. And gamma rays are the rays that I definitely want to stay away from because of the high energy and wallop that they can bring. Down below, we have red. It's a little bit lower energy. Well, what's lower? Well, infrared radiation is lower. That's why they call it infrared. It's below the red. So infrared radiation is not going to hurt me. There's some good health benefits, again, that are associated with it. Down below that are microwaves, and down below that are radio waves. And of course, you know, we pick up these radio waves in our car and vehicles all the time. We probably use a microwave in our kitchen all the time. So these waves are not very dangerous as far as exposure is concerned. So this is the electromagnetic spectrum. And this is what we call a spectrometer. And a spectrometer is an instrument that measures light. And we can pick out different portions on this electromagnetic spectrum to measure. And the UV Vis measures just that. The UV portion and the visible portion of the electromagnetic spectrum. So this is concluding our first video, our intro, so to speak, of what UV Vis really represents. So in the upcoming videos, we're going to talk a little bit more about the theory, a little bit more about the history of the instrument, and hopefully get you really comfortable with the concept of what this instrument is doing in a laboratory.